Today, we are going to start talking about solving exponential equations. Today, we're going to look at two types, right? Solving exponentials with the same base and with different bases. Okay? There's actually a third way that we will look at later. Okay? But today, we're just going to look at two ways to solve exponential equations. To do that, first, we need to quickly review these laws of exponents that we've already talked about. Right? It's been a while, but we did a whole lesson on these laws of exponents, and we practiced these. So the first law is the product property. If I'm multiplying two terms together that have the same base, I would add the exponents together. Right? So for example, 2 squared times 2 cubed would be the same as 2 to the 5th. I would add 2 plus 3 and get to the 5th power. If I'm dividing two things that have the same base, I would subtract the exponents. So 2 cubed over 2 squared would be the same as 2 to the 1st. That should say 3 minus 2, not 3 minus 1. Right. The third property that we talked about is the power property. If I am raising a power to a power, then I would multiply the exponents together. So 2 squared to the 3rd power. This is full of errors, isn't it? That should say 2 to the 8th power.
Who made these?
Hold on, wait a minute. That should not be the 8th power. This is all kinds of wrong. This should be to the 6th power. Yeah. And we would multiply 2 times 3
Okay,
and get the 6th power. This was pulled out of a textbook.
Was it really? I wonder if it was supposed to be 2 to the 3rd to the 3rd, based on their parentheses.
Yeah.
That's where they're at.
It must be, yeah. The fourth property that we talked about was whenever we have a negative exponent. Whenever we have a negative exponent, we can just take. Whenever we have a negative exponent, we can just take that to the denominator and make the exponent positive. So 2 to the negative first would be the same as 1 over 2 to the positive first. Okay, or 2 to the negative 32nd power would be the same as 1 over 2 to the positive 32nd power. The last property is the zero exponent property. Anything to the 0 power is equal to 1. Okay. Any questions on those properties? All right, then let's take a look at solving some exponential equations. So this is the list of steps that we're going to need for today. Right? Our goal is to get one exponential equal to one exponential. Okay? Similar to what we did when we were solving log equations. Right? If I had logs on both sides of the equation, I wanted to get one log equal to one log using properties of logs. Similar idea here. Okay? I want to use properties of exponents to get one exponential equal to one exponential. And I need to make sure that those exponentials have the same base. And we'll take a look at what this means here. And once I have that, once I have two exponentials equal to each other that have the same base, I would just set the exponents equal. Okay, I dropped the bases. So let's take a look at what that means. Okay, on the front here, we've got some straightforward ones. This is type 1, equations that already have a common base. So I've got 2 to the x plus 1 power equals 2 to the 9th power. If I already have common bases, all I need to do is set the exponents equal to each other. Right? So I'm just saying x plus 1 equals 9. Yeah, subtract 1, don't add 1. What's that? Alright, so whenever that we have a common base already, all we have to do is set the exponents equal. Okay? Go ahead and try the next one. Did we get -4? So we already have common bases. All we need to do is set the exponents equal to each other. All right. Now, on the next one, we've got something a little bit extra here. We've got 2 exponentials on the left side of this equation. Okay. I need to combine those into a single exponential. So if I'm multiplying 2 things that have the same base, what do I do to the exponents? Add them together. Right? So I want to add k plus k plus 2. What's k plus k plus 2? How would I do that? Yeah, so if I'm adding k plus k, I would get 2k, right? And then there's nothing for the 2 to combine with, so I would just have 2k plus 2. So 3 to the 2k plus 2. And then I didn't do anything to the right side, so it would still be 5k minus 1. Glad you get a kick out of 2k.
You kept saying it though.
I mean, you can do that with anything. Just pick one word and say it 100 times. It sounds weird. So now I've got 1 exponential equal to 1 exponential. Now I can take the exponents and set them equal. So should be a fairly straightforward equation to solve. Get the variables on one side, then get the numbers on the other. We get k equals 1. You okay with that one? All right, so the next one is similar. Okay, our first step, we will have to combine on both sides of the equation this time. Okay, combine the exponentials on both sides, and then set the exponents equal. So let's take a minute here. You can just try number 4. Did we get v equals 4? Questions on type 1 when we already have a common base. Okay, these ones are pretty straightforward, I think. Okay. Now on the back.
Oh, I think I got it.
Okay. On the back, we're going to take a look at type 2, okay, where we have equations that do not have a common base. That's a log. So if we see a log that doesn't have a base, we say it's base 10. But here, if I've got this exponential equation that does not have a common base, so I've got 6 to the 2x minus 10 equals 36. If you look back at your steps on the other side, you want to tell us?
I don't matter now.
You can say it.
Go just take 6 to the second power.
Yeah.
That would equal 36.
Bingo.
Yeah.
So our goal is to write both sides with the same base. So we can see this has a base of 6. I want to figure out how to write this with a base of 6. So Mikey just told us 36 is the same as 6 to the second power. So I can say 6 to the 2x minus 10 equals 6 to the second power. So now I can take my exponents and set me. So x minus 10 equals 2. Add my 10 over. Divide by 2. And x equals 6. You okay with that one?
Yeah.
All right. How about the next one here? Let's give everybody else a chance to think about it here. Okay, so here I've got 2 to the p minus 7 power equals 8. Again, my goal is to write both sides with the same base. So, what is it? 2 squared? 2 to the third. Yeah. 8 is the same as 2 to the third power. And if you don't recognize that right off the bat, you can use your calculator to help you figure that out, right? You can just take 2 raised to the second power. Well, that's 4. 2 to the third power, that's 8. That's what we want, right? So I can rewrite this as 2 to the p minus 7 equals 2 to the third. Then I can set my exponents equal. And this is pretty simple to solve. Right? Just add 7. We get p equals 10. Good with that one? Alright. Then the next one, let's think about this one here. So again, I want to write both sides with the same base. Yeah, ew, fractions, right? So how could I write 1/7 with a base of 7? Exactly. This would be the same as 7 to the negative first power. Right? That's that inverse property that we talked about. So now, I can set my exponents equal. 4x plus 11 equals negative 1. Subtract 11. Divide by 4. We get -3. Pleasure.
Thank you.
You feel okay with this one? They are. They're going a lot faster than I thought they would. Sometimes, yeah.
Well, these are actually going pretty fast.
We were just that smarter.
All right. You guys see if you can do number 8 here. So what you have is like this, right? So if we've got a power to a power, right, we want to multiply, so we distribute that.
It's not commandment, but it won't live in my
Guess what the shmoney was tells us?
Yeah, we can can it. How much are you sold? Really?
Not bad.
Yeah. Let's feel that, right?
Yeah, I mean, there's not. You can obviously tell.
What is the last one? The last one that was like that was the older thing.
Yeah, they all look like their dad, but they have like a firm.
That's Joey. Do you have one?
It has kind of like thick hair, kind of spine. Real thin hair. A lot of them have that.
They smart though.
Did we get 7 for M?
Yes.
All right. Questions so far? All right. Feeling all right?
Yeah.
All right. So on this next one, okay, we have to think about another thing that comes into play here. So, was it? Yes. So I still want to rewrite both sides with the same base. Right? So I see a base of 3 here, a base of 27. How could I write 27 with a base of 3? 3 to the third. And so when I do that, I'm going to replace the 27 with 3 to the third, but then that's still going to be raised to the 2x plus 6th power. So here, this is where our power property comes into play. I'm raising a power to a power. So I'm not going to add them together. If I'm raising a power to a power, I'm going to multiply them. So what I'm going to do is distribute this 3 to both the 2x and the 6. I'm raising this power to a power. So what I'll end up with is 3 to the 6x. 3 times 2x would be 6x. And then 3 times 6 would be 18. Now I finally have the same base. Now I can set the exponents equal. So 6x plus 18 equals 2x. Get the variables on the same side. So I'll move the 6x over to the right. Get 18 equals negative 4x. Divide both sides by -4. I think we get -4.5.
I didn't know if we could do
Yeah, decimals are certainly fair game, as are negative numbers. Okay, feel okay with that one? All right, so on this one, the extra piece that we had to take into account was raising a power to a power. Right. So see if you guys can try the next one. Okay, it's the same idea. We will end up raising a power to a power on the right side of the equation. So take a minute, see if you can do number 10 here.
Yeah. Talk about it.
No.
I did it. Why didn't you do my five or the back? Because my pictures were too big. You don't want to be up and down. Yeah.
I don't think you had to do it like right up in the middle. He said you could just write down the paragraphs.
Really?
Either that or it might have been the photos he was talking about. Because I know he said that about the photos.
But I just gave up on it.
it.
I did everything else, and I got my letter.
Would you do your argument or essay on
Different color hair, being a lot of
That's a good.
Miss Barrow was for us to do go over the return argument of essay for the commercial against.
We didn't even do that.
Do what?
Yeah.
It's not that. Cash, have you watched the Motley Crue video?
No, I haven't. I want to watch that though.
Yeah.
Is it good?
Yeah. Kind of sad though. It was good.
I've read Nikki Sixx's autobiography.
Yeah. Yeah.
But, yeah, I want to watch that.
Oh yeah. It's crazy though that Machine Gun Kelly plays Tommy Lee.
Contest.
Yeah.
Yes.
I would never take it. You did pretty good. I was surprised.
I got you.
And Miss Barrow. Number 11. Since I'm doing this one. Can you raise this one to that power? It doesn't really matter. You just gotta get.
You just gotta get them the same
Now,
base.
if you also change both.
Yes, that's what's gonna happen.
I can just make that one.
All right, on number 10 here, did we get 8? Okay, I can rewrite 16 as 4 to the second power. Right? So when I do that, 4 to the second to the y minus 3, I would distribute that 2 to the y and the -3. So I would end up with 4 to the 2y minus 6 power. Then setting those exponents equal, solving, we should get 8. Questions so far? All right, then this is kind of the final scenario that we need to look at today. So at number 11, I've got 125 to the y power equals 25. Now, in all the examples we've looked at so far, we were able to just look at one side, the smaller number, and say, I want to write both sides of the equation in terms of that base. Sometimes, though, we will need to rewrite both sides. Okay? There's no power that I can raise 25 to get 125. So, in this case, I need to rewrite both sides. Okay? What base could I use here to rewrite both 125 and 25? 5, right? So, this one's probably easier to recognize, right? 25 is 5 to the what power? Second, right? So this would be the same as 5 to the second. What about 125? It's 5 to the third, right? So this would be 5 to the third to the y power, right? Well, I would just multiply those together then and say this is 5 to the 3y power equals 5 to the second power. Okay, so this is probably the most challenging of these types of equations, right? Where we have to rewrite both sides. We have to recognize what base we can use on both sides of the equation here. So now I can just set the exponents equal, divide by 3, and we get y equals 2/3. Fractions too. Sorry. Questions on that one? All right, let's take a look at this one together then as well. So I've got 16 to the 3x power equals 8 to the x plus 2.
You gotta make them both big.
Right.
4 and 3.
Right off the bat, you might kind of think, well, I could use a base of 4. Right? It kind of looks like you could use a base of 4. I know 4 squared is 16, but then 4, I can't make 8 4 to some power, right? So we do have to go all the way down to a base of 2, like Mikey said. So he told us that 16 is 2 to the 4th power, right? So we'll have 2 to the 4th power to the 3x power, and then 8 is 2 to the 3rd power. So I'll have 2 to the 3rd to the x plus 2 power. Okay, and again, if you don't recognize that right off the bat, that's okay, right? Use your calculator to do a little bit of guessing and checking. Right? I mean, you may think 4 is going to be the base, so try to raise 4 to a power. Well, you can't get that, so start with 2 then. Raise 2 to some power, so you get 16 and 8. Now, I need to multiply my exponents, so 4 times 3x would be 12x, and then distribute this 3, so I'll have 2 to the 3x plus 6. Set the exponents equal, so 12x equals 3x plus 6, and just solve for x. So 9x equals 6, divide both sides by 9, we get 6 over 9 exactly, which reduces to 2/3. Right. Questions? All right, let's take a few minutes here, and you guys try the last 2 on here. Try the last 2 on here.
But yeah,
You drew it.
Yeah.
I forgot.
yeah. I was trying to figure out.
Wow. It's really good on Wednesday. So, you could get you one day. That was one week day.
I like this.
All got the car back. $958 over there.
Something's too high.
Yep.
Sorry, so
Something's too bad. What was it?
More inflation. It's just the
It's leaking, but it's not like you really can see on the ground.
slowly.
Yeah, it's not that bad.
all right, for number 13, did we get -1? So here we would need to rewrite both the 4 and the 8 with bases of 2. So 2 to the second, 2 to the 3x, 2 to the third, 2 to the x minus 1. Then I'd multiply the exponents together, so I would get 6x and 3x minus 3. Setting those equal and solving, we should get -1. Right? Then on the last one, kind of threw everything we've been talking about here into one problem. Right? So I've got 1/3 and 81. I'm going to need to rewrite both of these with a base of 3. So 81 is the same as 3 to the 4th power. And then 1/3 is the same as 3 to the -1st power. So I can rewrite my equation like this. Now I can multiply my exponent through. So this would be 3 to the 8x plus 20 equals 3 to the -2x power. Then just set these exponents equal. So 8x plus 20 equals -2x. Get the variables on the same side. So 20 equals -10x. Divide by -10, and we get x equals -2. We okay with that one? Any questions on this stuff at all? All right, then that's it.